yesterday, and in lesson 25, remember what we were doing, and that was that we were developing a model, a mathematical model for some physical situation, all right? And what the book does is to call that physical situation a problem, or what we might call a word problem, all right? And the mathematical model is going to be this equation that we are going to develop and solve, all right? And let's look at a number of examples and see if we can't work them through, all right? And right here in our first example, it says 37 more than 3 times a number is 13. What is the number? All right, so what's the number? And let's call, and Dave says? X. All right, so let's let X equal a number. And remember, we use the equality symbol to indicate represents a number. Well, if X represents a number, the sentence says 37 more than 3 times that number is 13. So who now can think of a sentence which he can translate into an algebraic statement here? Steve?
3x plus 37 equals 13.
3x plus 37 is equal to 13. Does everyone agree with that? All right? And you say, of course, I think that's true. I think that's pretty easy. 37 more than 3 times that number equals 13. All right? Now, there's our model. This is our equation, and we now are asked to solve this equation. So we look at it, and let's write a simpler equation. And perhaps the first obvious simplification of this, Ron would say, is to subtract 37. And let's do that in our head and write 3x is equal to, Steve?
Negative 24.
Negative 24. And we look at that. We don't want the 3 there, so Steve says
Divide by 3.
divide by 3, and let's write x equals
Negative
8. All right? Now, what I'd like to do at this point is to indicate what we might call a check. All right? Now, let's take this number, negative 8, and now the original question, let's not look at this sentence here, but let's go back to the original English sentence and see, when we look at this number, negative 8, in that context, whether or not our statement is correct, okay? 37 more than 3 times a number is 13. Now, 3 times a negative 8 is negative 24, and 37 added to a negative 24 gives us 13. And you say, oh yes, the statement checks. Is that right? So 3 times a negative 8 plus 37, in this case, is equal to 13, and indeed the statement checks. Now, what I'd like to do is to come to a conclusion. And the conclusion is going to be an English sentence which answers the question asked up here. And what was the question asked? What's the question that is asked in our problem? And Todd says,
What is the number?
What is the number? All right, now let's then write a declarative sentence which says what? What do we want to write here? The number is what? The number is negative 8. All right? Now, you might think that I'm a little fussy here, but I'm going to insist that you follow a certain procedure when you do these word problems. Okay? Now, the first statement that we want to write, or the first idea when we start doing these word problems, is to identify our variable. Okay? And so in this case, let x be the number. The second step that we want to go through is to write down the equation for that problem. Okay? The third step then is solve that equation. In this case, we have solved this equation. The fourth step then will be to check the result that we get from our model back in the physical situation with which we started. Okay? And then the fifth idea is to write a conclusion. Answer the question that was asked. Okay? And here's this 5-step procedure that I would like you to get into the habit of using every time you do a word problem. All right? And I think that if you follow this procedure and if you continue using it all the time, I think you're going to find that these word problems get a little bit easier as you go along. All right? Let's look at a second example right here. It says, find the degree measure of each of 2 complementary angles if one measures 27 degrees less than twice the other. Now, the first question is, what is meant by complementary angles? And Todd says,
Well, that's 2 angles, and if their sum of their degree measure adds up to 90 degrees.
then those angles are called complementary, all right? Now let's indicate this little angle here to indicate an angle of 90 degrees, to represent an angle of 90 degrees, all right? And here then, let's say is some angle associated with this is some number A, and a number associated with this is B, measured in a degree measure, okay? And which what? A plus B is equal to 90, and we then will call A and B what? The word is complementary. And as a matter of fact, let's indicate over here, even though it's not part of the problem, in which we have here what we might call a straight angle, which measures what? 180 degrees. And if here is some angle C, and here is some angle D, in which if we measure those in degree measure, and what can we say? If C plus D is what? 180, then C and D are called, and Brenda says, supplementary angles. So in our case here, we are dealing with complementary angles, all right? Now, it says find the degree measure of each of two complementary angles if one measures 27 degrees less than twice the other. So how are we going to start? We want to identify our variable, so what do we want to say here? Let's let x equal, or represent, and what do we want to say about x? And what do you think? Well, let's just say, let's let x be measure 9. Number of degrees. Let me indicate this. The number of degrees in one angle. I don't know which one it is. I really don't care which one it is. Now notice it's a number. All right? X is a number. All right? Now once we have stated that, let's go back to our original problem. And what do we know about the other one? If one of them measures 27 degrees less than twice the other. So let's interpret that in terms of what we mean here by the first one. And who can say something about that? Ron? 2x minus 27. All right, one measures 27 degrees less than twice the other. So 2x minus 27 is the number of degrees in other angle. All right, and let me indicate it by these dittos. All right, now let's write a sentence. Who has a sentence that's going to pull it all together here? David?
3x minus 27
All right.
equals 9.
Well, let's go back and use our definition of complementary angles first, and then we'll write a simpler sentence. And Ron says,
x plus 2x minus 27.
all right, let's indicate that as our other angle, so I'll put it in parentheses, and of course the sum of the two angles is equal to, in this case, since they are complementary, by definition is equal to 90. Okay? Now, David, why don't you give us your sentence?
3x minus 27.
3x minus 27 is equal to 90. And you say, well, I don't want this negative 27 here, so what can we do to both sides? Jane says, add 27, and when you do so, what do you get here? 3x is equal to,
100.
and what do we get? Yes, Jane? 117, is that right? Okay. And then you say, well, I don't want the 3 there, so let's do something to both sides. Sally says, divide by 3, and when you do so on the right, you get x equals, what do we get there? 3 divides 11, 3, that's 39. Okay? Now, notice I'm not going to put a degree symbol here. It's a number. X is a number, which indeed says a number of degrees in one of the angles. All right? Now let's indicate what the other number is. So there we have 2x minus 27 is the degree measure of the other angle. And what then do we want to say? Twice 39 is what? 78 less 27 is
51.
51. All right, so the other number is 51. Now, let's write our check right here. Is 39 plus 51 equal to 90? Is our question. All right, these have to be complementary. Therefore, their sum must be 90, and everyone says yes. So I'll erase that question mark and put a little check mark there. Therefore, what is our conclusion? We want to now write a sentence, and Chip says,
that x will
well, we want to write an English sentence, which is our conclusion to the problem. And what do we want to say here? Chuck?
that
Well, just, here are these two numbers that we've come up with. Brenda says,
The degree measure of each of the complementary angles is 39 and 50.
all right, how about simply the angles are? The angles are what? 39 degrees and 51 degrees, okay? Now here, notice it is written in degree measure. If we're answering the question asked, which was in terms of what is the measure of these two angles in degrees. Here is our mathematical model. We have solved that and came up with a number, and then we translated that number in terms of our original question. All right? Let's indicate our steps here again. Notice, here is our first step in which we have identified our variables. Our second step was to write down a sentence. A third step was to solve that sentence, this equation. The fourth step was to check the numbers in relation with the original problem, not in relation to the sentence that we got here. And the fifth step is to write an English conclusion. All right? In every problem, I'd like you to follow this procedure. Let's go to the third example. Here we have something about Sam, Henry, and Jack. Sam is 4 years older than Henry, and Henry is 3 years younger than Jack. If the sum of their ages is 37, how old is Sam? And I think part of the reason why I included this example here was for you to be able to identify what you think is the variable x, and what you might call the variable x, and perhaps the easiest way of dealing with the situation. And Todd says,
I call it Henry.
you'd call it Henry. All right? We probably could start out with Henry. Let's try, perhaps we can try Steve. Sam. He wants to start with Sam. And of course there's only one guy left. And Ron says, let's start out with Jack. Well, let's let x be the number of years. Again, it's a number. Number of years in what? In Jack's age. Now, there's no reason for you to come to the conclusion that it is easier to start out with Jack to be the variable, the value for x, rather than Sam or Henry. And perhaps after we go through the problem, we then will go back and look at it, and then perhaps you can decide whether or not it was easier to do it this way. All right? Let's see now. If x is the number of years of Jack's age, Henry is 3 years younger than Jack. So give me a statement, an expression to relate that, Ken.
X minus 3.
All right. X minus 3 is the number of years in whose age? In Henry's age. H-E-N-R-Y. Henry's age. All right. Now, let's go to Sam. Sam is 4 years older than Henry. And what then Sally says?
X minus 3 plus 4.
X minus 3. All right, let's indicate that. X minus 3 plus 4. And I think there's a simpler name for that, which is, Brenda says,
X plus 1.
X plus 1. All right, this is the number of years in, who is he? Sam. In Sam's age, okay? Now, what is the sentence that we want to write? And who has the chip?
X plus X minus 3.
All right, X plus X minus 3
Plus X minus 3.
plus, all right, well, let's write a simpler name for X minus 3 plus 4, which is X plus 1. Right here, I think we can write that. And, of course, the sum of their ages, we are told, is 37. And so there's our sentence, right? You say, oh, that's pretty easy. Now, look, if we had started out, say, with Henry's age, where X is the number of years in Henry's age, all right, that Jack then would have been what? How then would we have represented that? And Jay says
X plus 3.
X plus 3. Everybody agree with that? That then would have been X plus 3. Because if Jack then is 3 years older, right, and whatever Henry is, right, if it's X, then he would have to be 3 years older than that. Hence the expression which would represent that is what? X plus 3. Is that right? How about Sam? Sam is what? 4 years older than Henry. So how would we represent that?
X
X plus 7.
X plus 7. I guess we would have to represent it by X plus 7. Is that right? Because he's 4 years older than Henry. Okay? Well, I think we have a sentence here. Is that right?
Would
Todd?
it be
Would be X minus 4.
Well, let's see. All right, let's write it all down then. Well, let's start out here with what? If this is X, all right, this fellow here would be what? X plus 3. Oh, I'm sorry, you're right. Then this would have been what? X plus 4 right in here, rather than starting with, right? Sam is what? 4 years older than Henry, not Jack. Okay? So I think then it would have been read what? This would have been X, this would have been X plus 3, and this would have been X plus 4. All right? Well, let's stick to what we have here, as long as we've gone this far. Give us a simpler sentence here, another equivalent sentence. Barb says,
X plus,
X plus X plus X
yeah,
is,
X plus,
well, Sally says,
or X plus X would be 3X.
is 3X. Okay, there's 3X. And then we have here what? Negative 3 plus 1 is, Jane says, negative 2, which we'll write as minus 2, and 3X minus 2 is equal to 37. And what's a simpler sentence here, Mary Lou?
3X plus 35. 3X equals 35.
All right, 3X is equal to, now be careful, not 35. We're adding 2 to both sides of our equation. Is equal to 39, and of course then Mary Lou says X equals 13. All right, now notice I'm not going through the process of saying, let's see now, I'm going to divide both sides by 3, but I expect you to be able to do that in your head. Now, X is 13, so let's go back to what our variables are, and that says what? That Jack must be 13 years old. How old is Henry? Let's just put down numbers here, rather. X minus 3 then is equal to what value? 10. And what? X minus 3 plus 4, which is X plus 1, must be what? X plus 1 must be what? He must be 14. All right? Well, if X is 13, X plus 1 is 14. Is that right? Now, let's check. And let's go back to the original problem in which the sum of their ages is 37. So let's just add what? 13 plus 10 plus 14, and this question is that equal to 37? And yes, we all agree that that's equal to 37. So therefore, our conclusion is what? Now let's write a sentence which says what? The question is, how old is Sam? So Bob says,
Sam is,
all right, where's Sam? Sam is X minus 3 plus 4 years of age, in which X turned out to be 13, so Sam is
14 years.
14. All right, let's write a sentence. Sam is 14 years old. Okay? Again, let's number our steps. This is number 1, to identify our variables. Number 2 is to write a sentence. Number 3 is to solve that sentence. Number 4 was to check, and number 5 was to come to our conclusion about the original problem. Okay? Let's go to another example, and I think that's all that we need to do for today. Here we have one angle of a triangle ABC measures 35 degrees less than another angle. The degree measure of the third angle is 30 degrees more than the sum of the measures of the other two. If the sum of the angles of any triangle measures 180 degrees, find the degree measures of triangle ABC. They say, well, let's see now. I think I had better start with a picture. And let me start with some picture in this fashion. Say here's triangle ABC. Now one angle of a triangle measures 35 degrees less than another. All right? Well, perhaps my figure isn't too good. Well, let's just decide to call some angle here. Let's identify this on our picture first as some number x. Well, this then is another angle. And what do we know about it? It's what? 35 degrees less than the other. So what's a name that I can give this angle in here? Ken says
X minus 35.
x minus 35. Does everybody agree with that? All right. Now, the degree measure of the third angle is 30 degrees more than the sum of the measures of the other two. So what's the sum of the other two? Yes. 2x minus 35 is the sum of the other two. And the third one here, we're told, is 30 degrees more than that. So give us a simpler name for this third angle in here. David says
Oh, wait a minute. 2x minus 8.
2x minus, not minus 8. Kirby says 2x
Minus 5?
minus 5. I think.
Oh, I thought that was an 8. It looks like an 8.
Oh, it looks like an 8. I'm
No,
sorry.
the bottom one.
This looks like an 8.
Yeah.
Yes, x minus 35, and to it we want to add 30. So we end up with 2x minus 5. Is that right? Let's write this down. let's let x be the number of degrees in one angle. All right, I won't identify it by A, B, or C. All right, what then is the number of degrees in a second angle? And we're told from the original problem it's 35 degrees less. So Brenda says x minus 35 is the number of degrees in, let me write it as second angle. All right, now what then is the number of degrees in the third angle? And Sally says 2x minus 5 is the number of degrees in third angle, okay? Now, what is the sentence that pulls it all together? And Ron says,
The degree measure of the triangle is 180 degrees.
right, the sum of the degree measured, the angles of a triangle, is 180 degrees, all right? For every triangle, by the way, it's equal to 180. I think you all know that, but I included it in the problem just to make sure. All right, so then give us a sentence. Give us a sentence. Kirby?
X plus x minus 35 plus 2x minus 5 equals 180.
All right, does everyone agree with that sentence? The sum of the measures of the angles of the triangle is equal to 180. And there's our sentence. All right, now let's write a simpler equivalent sentence to this. And Chuck says,
3x,
well, I have x plus 2x is,
4x,
there's a 4x
minus
30,
minus 40.
minus 40 is equal to 180. 4x is equal to, David? 220. And x then is equal to, Brenda, 55. Now, if x is 55, x minus 35, again, these are just numbers here that we're dealing with. X minus 35 is what number? Is, Mary Lou? 20. And 2x minus 5 is what number? That's twice 55 is 110, less 5 is what? 105. Now, let's check. And our check is to do what? Go back to the original conditions of the problem. We found what we think are the three numbers associated with the angles of this triangle in degree measure. And if we add them up, what do we get? We have what? 55 plus 20 plus 105 equals question mark 180. Do they? Do they add up to 180?
Yes.
Yes? All right. And there's our check. Therefore, let's write our conclusion. Let me indicate it over here. And what? The degree measures of the angles of the triangle are. All right, let's put it that way. Well, let me just say the angles of triangle. Let me use this little triangle symbol, ABC. The angles of triangle ABC are what? Are equal to, are what? 55 degrees, 20 degrees, and what? 105 degrees. Okay? Again, here is our first step. Our second step is to write the equation. The third step is to solve the equation. The fourth step is to check it. And the fifth step is to write our English conclusion. Okay, why don't I then ask you to do some problems for homework, and I think that that's all that we need to do for today. So let me give you assignment 26.